Welcome to your e-learning video. In this video, we are going to look at doing a hypothesis test with slope. Now, in the last video, we looked at doing a confidence interval with slope. The reason why we would do a hypothesis test is really just to verify that this slope is significant. The value that we got for slope is definitely a positive number or definitely a negative number, because when we do that, then what we've really said is that we know for a fact that this relationship has a positive association or a negative association. So by doing a hypothesis test with the slope and verifying that it's greater than zero, or verifying that it's less than zero, or verifying that it's different than zero, what we've actually verified is that there is a relationship between the two variables that we're looking at. And so in order to do a hypothesis test, first of all, we have to make sure that our data has come from a random process. I just realized that says population mean. It really should say a hypothesis test for the slope up there. So if you want to mark that out and just put in slope with a regression line right there. But in order for that to happen, first of all, the data has to come from a random process. We've said that for pretty much everything this year. But also we want to still look at that residual plot that we've talked about before and make sure that there's no apparent pattern inside that residual plot, because that verifies that we have a linear equation and some of these other requirements are met. But our hypothesis test in general for the slope of the regression model, it's going to be done in much the same way the rest of them are. Our null hypothesis is going to be that it's equal to zero or equal to some null value. Typically it's going to be zero because we're trying to show an association, but we could have it set up so we wanted to make sure that the slope was greater than 0.5 or something like that. So our alternate hypothesis is either going to be that it's less than or greater than, or maybe even not equal to zero, or whatever null value is that we decide on. To find the test statistic, we're going to take the point estimate of the slope, which we can get from Google Sheets, minus whatever that null value is that we decide on in our hypothesis test, divided by the standard error of the slope, which again, that's something we can get from some kind of computer package like Google Sheets. And then the p-value, we find that p-value to look up using our t-distribution. And remember, there's going to be n minus 2 degrees of freedom, because there's two things that are going on in that regression equation. There's the slope that we've estimated, and there's the y-intercept that we've estimated. And so that's why we end up having n minus 2 degrees of freedom on this test. So as we kind of look at this example, we're going to be doing an example of again, the water fountain in the bathroom trips like we've done before. And so we've looked at Google Sheets and we've gotten this information. Okay, we've gotten the fact that the slope has got a value when we look at Google Sheets of 0.845 with a standard error of 0.226. And here's our y-intercept and the standard error for that, and then our value for r squared, and this overall standard error of the estimate, which we're going to talk about a little bit more in the next video. So the first thing we want to do is we want to come up with a null hypothesis. And so if you notice up here, it says we're trying to figure out if there's sufficient evidence at a 0.04 level to indicate that more trips to the water fountain is associated with an increased number of trips to the bathroom. So that's what we're looking for, because again, that's what that slope is indicating, is that relationship between those two variables. So our null value, like always, is going to be that it's equal to zero. So in this case, the slope is equal to zero. What would our alternate hypothesis be, though? Okay, we want to have an increase, and so therefore it's going to be greater than zero. So our alternate hypothesis is going to be that the slope is greater than zero. Okay, what value will we use for our point estimate for the slope? Okay, that's going to come up from the table up here. That's going to be the 0.845. And what are we going to use for our null value? Okay, the null value is the value that we're using in the null hypothesis, and so that would be zero. And so as we set up our equation, first of all, we need to figure out the standard error. So again, the standard error is going to come from our output up here, so 0.226. And how many degrees of freedom does this have? Okay, well, it doesn't say up here in this problem, so just remember that we had 20 samples that we took, and so that's why we're going to have 18 degrees of freedom when we set this up. Nope, sorry, wrong problem. I was thinking of the grocery store problem. The water fountain problem, we had 9 students that we tracked, and so there's 7 degrees of freedom. Okay, so now we want to find the t-score. So take that information that we know the slope, we know the standard error, we know the null value, figure out what your t-score would be. So it's going to be set up like this. And so the value that you get for your t-score is going to be 3.74. So we need to find the p-value that goes along with that. So remember, we've got 7 degrees of freedom. We've got a t-score of 3.74. So look at your chart. What range will your p-value fall in? Okay, so we're going to find that our p-value falls between 0.005 and 0.0025. So are we going to accept the null or are we going to reject the null? Okay, I really should have said, are we going to reject the null or are we going to fail to reject the null? P is less than alpha, so that means we're going to reject the null hypothesis. And so that means that our conclusion would be, since we've rejected the null, that there is sufficient evidence at this 0.04 level of significance to show that the slope is greater than 0. And what that really means is that we're showing that there's a positive association between the number of trips to the water fountain and the number of trips to the bathroom. So that's going to be the general format for hypothesis tests. You can see it's kind of that same format we've been using ever since we first started doing hypothesis tests. You're going to start with your null and your alternate. You're going to figure out some kind of a test score. In this case, it's a t-score. Use that to find a p-value and then make a decision about the null hypothesis based on that p-value. All right, so that's what you're going to be looking at today, is doing some of these null hypotheses so we can test to see whether we have good data or bad data on something, whether it's actually giving us a good result or whether it's not. So I just wanted to leave you with this cartoon here as we finish today.